All right, let me start with our very first AppSec and Secure coding workshop, where in this workshop, I'm gonna go through quite an interesting security bug that today you can find in the majority of the apps, web APIs, and mobile apps, firmware, or even things like all the way down to smart contracts. It's one of those interesting security issues. And the way I'm gonna approach this is by taking you through entire spectrum of this security defect, finding it using black box or white box or code review techniques, hacking it or exploitation, but most importantly, fixing it, or how to remediate and what are the common pitfalls are in addressing this security bug. So if you are a pen tester or a bug hunter and you are looking for a different class of security bugs, you want to report on different quality of the security issues, well, learning the code and understanding what it takes to address a security bug at a code level, is a key skill set, or AppSec in general, that you want to take away. Now, listen from someone who has done penetration testing for years, and when I started have more understanding about those lower layers, especially the code, I can tell you the quality of the security bugs improved so much. Now, if you are a software engineer, on the other hand, well, you have one advantage, that is you already know about the code. You know how to build the code, build the app. But the thing here is that a lot of times we build software that are usable. And a software that is usable is not necessarily secure. And to make a usable software secure, we need time, we need a bit of dedication, but most importantly, we need to upskill and understand those edge cases that can result into a security issue. And those edge cases are those ones that we may not consider them as a high priority. We may just look at them as a edge case scenario, or we may just filter them out. And it's not just about knowing those edge cases, but also understanding the root cause behind them. Because what I would really like to avoid is to just go after those edge cases and spot patching them, and without getting rid of the whole problem, which when today I went through some of those common pitfalls in patching, we will see some of those not so good way of addressing the software. So with that, I like to start with an interesting question, just as a preamble. That well, why there are so many software security bugs out there? Well, can we naively think that this is because the software engineering team were not good enough to write those securely? I should say early in my career, I may have been guilty of this mindset. But the more I learned about the code, the more I understood the complexity of how we turn a concept into a code, and later on, how to turn this code into an app that run in production. I realized that it's way more complex than a person or often a team or just one person's mistake that these security bugs emerge. Now, don't trust me on this, because I'm going to go through one example just to show you the complexity around, well, why it's even hard often to write some implementation for a reality of a concept. And these things will make more sense as I go through it. So imagine we have a software that accepts a person's age. Simple. A known concept that a lot of us know about it. Now, if you want to write this software, and if you want to test this software, what type would you choose for this person's age? Like if you want to represent that in your software. And here are your choices: float, integer, long, or none. Perhaps you can use the chat to tell me a little bit more. What would you pick? Like, let's say you want to pick a data type. or you want a way to represent this percentage in your program. Which one of these types you will pick up? Is it float? Is it integer? Is it long? Or none of the above? Just waiting for a couple of answers to show up. There is a bit of delay in the broadcast, but I would also pick, yep, number 2 in most cases, because anytime we are dealing with decimal base 10 values, it's a very common choice that we pick integer as a data type to begin with. Well, suppose we pick that. If we model the reality of age as integer in our program, there are quite interesting stuff happen, and actually we already start having security problem. Why is that? There are things that it make perfect sense in the context of integer, but it absolutely doesn't make any sense with the concept of age. For example, can age be a negative value? Clearly not. But guess what? Integer can be negative. Or can age be 2 power 63, or a person aging in this case be 2 power 63? Well, I don't think so. But guess what? An integer value for a computer system, it can be perfectly 2 power 63 minus 1. Or can we subtract the age, or I don't know, make a square root of the age? These are things that perfectly fine when we deal with integer, but not so much with age. So regardless, in our code, we call a variable age, or I don't know, name. That doesn't matter. For a computer system, that data type, or the way that we model that is what really defines that thing. And in other sense, for us, in the real world, the age is something between, I don't know, 0 to 120, or you can go higher than that. But when we define it as an integer, these all gray things that we see around age, these are also means for a computer system, well, that these are also age, because, well, you define it as integer, well, that's what effectively your data model is. Now, in one sense, from engineering perspective, I may say, well, that is not so bad because, well, I wanted to have age, something, but now that thing that I have defined is more powerful. It can do even more things without even me lining an extra line of code. That thing have all those power within and also represent age. Not a really good thinking, because that gray area we see, these are those scary undecided, weird states that our code or our app can get into, including runtime exceptions, including security vulnerabilities. And perhaps it would be interesting to say that a security bug, in other sense, is a runtime exception. These are states that our program can get into, and in our program, we gracefully could not manage them. And yeah, with the example of a few numbers that I had here. So the purpose of this just example or preamble was even to define basic concepts in our program. Even within the design of program, by choosing something wrong, you're going to have a lot of problem down the line, or we need to worry about a lot of other things. So with that, I want to move into our very first security bug or defect or vulnerability. I will start with a real-world incident that is related to this security bug, just to make sure that, yes, these are not just things in a game or you may hear in the CTF, what actually happens in many places. And if we have time toward the end, I'm more than happy to take you through quite very interesting new incidents of this security issue that is actually pretty old, but for some reason it's still just popping out everywhere. Reboot Boeing 787. So it was a few years ago, to be specific, it was around in 2016. The Federal Aviation Administration announced to all the airliners that if you have a Boeing 787 and if you haven't shut it down or turned it off, or I don't know, it was in operation for 248, guess what? It will shut itself down due to a software bug. Or in other sense, which later on we will see, it was a security related bug. But let's just think about it for a moment. I mean, for me, this is like, wow, like a plane will shut itself down just because a single bit of information is flipped. And well, that's for me is very costly. So in fact, just to talk a little bit more about this incident specifically, the onboard unit that was controlling the power generator, it had a counter defined as hint integer, and that counter when it was reaching to that value 248, was something interesting happening to that counter, and that would cause the weird state, undecided state, a runtime exception, and then that plane will decide, say, hey, I cannot handle this. I would rather shut down the power control unit. Now, the good thing about this story is that it didn't happen in the sky. They actually found it in the lab, and they announced it. To really understand what actually happened, I need to take a few steps back and talk a little bit about how numbers are managed in a computer system. And I want to go all the way down to hardware level. So hopefully this gives us a good overview of what is going on, and perhaps we can avoid this sort of security bugs happening. When we talk about CPUs, and I'm sure most of you are familiar with the CPUs, CPUs has a number of components, and one of them is called register. And think about a register as tiny memories that is on those within that hardware. Now, traditionally or usually, the majority of the arithmetic operation that the CPU does at the hardware level I'm talking is done by using the register, those tiny memories that are available on the register. Why is that? I'm not going to go through the details of it, but just think about you have a tiny memories on the CPU that can operate on, I don't know, numbers, can add things, because by the end of the day, back in the days, these computers were giant calculators. And when we're talking about limitation and restriction of these spaces, that means that I cannot throw in every big number that I can imagine to these computer systems. There are limitations there. They cannot really operate on every single number that you can imagine on a CPU level. To be specific, in today's more computer systems, the biggest number that you can operate on, or the range, is this number that you see here. If you are familiar with the term 32-bit system or a 64-bit system, in fact, that 64-bit and 32-bit is a hint for you that tells you a little bit about the size of actually that register on that CPU. So this number here is 2 power 64 minus 1. Or this other number here, which is for a 32-bit system, a little bit older system, is 2 power 32 minus 1. So all good. Now, please take a note of this number here. I will just copy, paste this, also put it in the chat just for us to have a reference of it. So 4 with, I don't know, 9 digits in front of it. Now let's look at this code. We have 3 variables, surcharge, fee, and total fee. Surcharge is 1, 2, 3, defined as integer. We have a fee, which is 2 with kind of 9 digits in front of it, and we have total fee. What do you think total fee would be, like after adding the fee to surcharge? And clearly, what this perform transaction function will operate on. So total fee is the argument to this perform transaction. Now, if I just look at this code, if I just know about decimals and the things that are done, I was like, yeah, this number plus this number, that would be the total fee. What do you guys think? Maybe you can help me in the chat. What do you expect when you see these values that are being assigned? And also one thing you can also assume is a 32-bit system. The other thing you should assume is that, well, let's just say this number fee comes from the untrusted source. Well, it comes from the user or another API. So let's just see if we see any response, any people. Anyone took the calculator out to put those numbers together? That's a very good point. So you can see some people mentioned that will be a negative value. Now, let's just come back to that. So you mentioned it's a negative value, which is the correct answer. But you see the numbers that I have pasted in the chat. That number, 2 with 9 digit, is way smaller than that other number, 4 with 9 digit. So why this happens? Like, what is going on? That clearly that number on a 32-bit system, they could manage it because it's smaller than that range that happened. So why this happened? Like, why it suddenly even turned to negative? Why it just doesn't stop perhaps? Or it's not even smaller than that? Let me just not taking this too long. Yeah, the answer is it is negative. It's quite a negative large value. And perhaps a fun fact, in some financial systems, a negative number often may mean refund. So instead of we charging a fee to a customer, we may giving them some huge lump sum. People don't been active in the smart contract space. They have a lot of incidents related to these issues that yes, suddenly things went wrong and then a lot of fund fly away from the account. So just to understand this, I just need to go one level deeper. Now, as some of you mentioned in the chat, we reserve one of those bits, so 32-bit, we reserve one of those bits to represent negative numbers. Because negative numbers, again, is a concept we have in the real world. It doesn't really have any meaning in a binary system. So just to model that in our hardware, we just say, all right, we have first bit of like one of these bits, we just put it aside. If that is set to 1, that means whatever value we have represented in this binary format, that means positive or it's mean negative. And that gives us this range. Okay, perfect. Another question. So why things wraps around? Like, so couldn't just, in the design of the hardware, we could say, hey, this is a number, take that, add it to this number, okay? Now the result is bigger than this value. I cannot represent that value because it's beyond the range I can handle. I will just stop, or I will throw an exception, or I don't know, I will set some flags. So why suddenly giving me a completely a weird negative number? That is to do with, again, another things perhaps we should take away is the concept of modulus arithmetic that are implemented in the majority of the microprocessors, not all of them, but CPU is one of them. Again, if we have time, perhaps we can talk about some other microprocessors which they do not have the modulus arithmetic. In fact, they're following the same idea that I said. They clamp down before they pass over a maximum value. So, and what is modulus arithmetic? Really simple. We are using it in our daily life. An example of it, well, in a medical domain, like, I go to a doctor will prescribe me to take a medicine every 4 hours. And let's just say now is 9 p.m. And then every 4 hours, the next time that I need to take this medicine, I know it's 1 a.m. because, well, an overflow happened in my brain. 21 plus 4 is 25 in the context of 24 hours. 25 does not have any meaning. So what I do 25 divided by 24, the remainder is 1. Whether or not I have done it or guessed it, that's how it actually modulus arithmetic works. So maybe it makes perfect sense in the context of time, but why do we have it in our design of microprocessors? Out of context for the workshop, but that is pretty much how they operate on. So, and coming back to that example, why we suddenly got that huge negative number was because that fee plus the surcharge, you're adding it, that number, this number is beyond int32 positive range. Effectively, it gets divided by 2 power 31. And this thing here, again, this is the representation of this massive negative number because the sign bit is set, and also the concept of 2's complement, which I'm not going through it now. So we have the root cause of this problem when we are dealing with a number, when we are done doing a proper range check is, first of all, we are using a data type that is fixed sized, and there's no range restriction is that. And the other thing is that the value will wraps around anytime due to the modulus arithmetic. Anytime the things goes beyond that range, that value will wrap around. What is the danger of it? Well, there was a case of Boeing, but this has resulted to a lot of unexpected results, especially when positive become negative. It impacts the data integrity of program, and I will talk about incidents hopefully later. Now, some of you already guessed or know what this security bug is commonly referred at, and a lot of people talk about this as integer overflow, but I like to call it numeric overflow more than integer overflow because it's not specific to integer. In fact, one of the common pitfalls I've seen people trying to address integer overflow is by casting it to long and thinking that, okay, now because this is not defined as long, we are safe. Well, now, guess what? You have long overflow. In the context of the float, we have some sort of overflow as well. Perhaps in some future workshops, we talk about it. But effectively, if you want to refer to it as numeric overflow, we're talking about those data ranges that they are fixed in the memory. And when things go beyond or below the range, due to the modulus arithmetic, the value is wrapped around. Now, before we jump into the, actually now what we can do, let's jump to the lab. I think the link for the labs has been passed on to you. So I will also do it here again. So this is a link. Make sure after the sign in, you are in the right game. Now, based on the responses that I've got for the languages we picked for lab, Python, JavaScript, and Java was the most popular one. So we have picked it here. So what we're gonna do is, for now, we're gonna look at an example of an app that have this integer overflow issue. And then for now, we're gonna run it, we're gonna test it, we're gonna look at how to find it from both black box and white box perspective. And then we will talk about hacking it and patching it. No, this is not about type safety, for sure not. Okay, so what I've done, I've just started this lab. Now what we have got now is a source code of the app, which is vulnerable to integer overflow. And there are multiple ways we can interact with it. We can either use this file explorer to navigate through the file, or if you have your preferred, you can clone this whole app or repository locally on your workstation. Everything is fully containerized. You can run it, you can test it, you can debug it, you can open it in your favorite IDE. Or what I'm going to do for now, I'm going to run it using this cloud development environment. You can hit this button here. It will give you a Visual Studio Code in the browser. So effectively what I can do locally, I can do it at runtime in the browser. It will take a few seconds for that to boot up, but then we're going to get a view like so. Now what I'm going to do here, right click and open in an integrated terminal. It will going to bring up a small terminal for me. Now, if you have done this lab in other language, when this terminal opens up, so to open up a terminal, right-click, open integrated terminal. Pay attention to these commands that are written here, because that will guide you how to run it. So for this JavaScript one, of course, npm start. See what I have done here? Yeah, was previously already run this. Let me run it again. Start. That will also show this pop out to you that your application is running, and click on open in browser, and this will open this app. This is the actual app where the source code of it is available for you here. Yeah. So now, without me going through the source code, I'm just first trying to understand what this app does. Enter an amount number for approval check, or sure. So it's an example of a query parameter that I can pass on. Just put it here. And it tells me 100 does not require approval. All right. What if I go, for example, 1000? 1000 requires approval. So it sounds like a check that it does for an amount that is bigger than a specific threshold it requires or does not require an approval. So from a black box perspective, one of the first thing I would definitely do anytime I deal with any endpoint that you will see deal with a number, I will try some of these numbers that you can see here. Now these numbers are carefully selected in terms of what probably they do, but some of them maybe you have already guessed. They try to hit the maximum integer value or minimum integer value, maximum long value, minimum long value, also maximum int64 value, and a few more. So just looking at the chat, yes, you can start. So I will can have these numbers in your toolbox to have a look later on. But now coming back here, what will happen if I just give it a large number, or maybe like a couple of zeros, like this is definitely bigger than, for example, if I say 2000 says requires approval, if I go like 3000, same thing, but let's just go, 9 digits. So suddenly, when I provide it with quite a large value, it says now it does not require approval. So the security check bypassed. And now is the time, let's just look at the code. Come back to the IDE. I will leave this running here. Just bring it. And I'm just going through the code. It doesn't matter. You don't need to, when you do a code review, you don't need to understand all part of the everything at first time when you look at it. So it's a Node app, and it's use an Express framework. There are a few routes here. Don't worry about it. Now, first thing gets my eyes. All right, so this is a prompt that I have seen. So enter an amount for approval check, and it takes this query parameter, so request query amount. And then it takes it. The first thing. So in JavaScript specifically, anytime you see things like parseInt, and there's another thing down below, these are the things you want to check for or query for, because when you do code review, one of the very easiest thing you can check for is the existence of this bug, and you just search for all the different data types that is being defined. Now, some of you may have already think about, hey, but JavaScript is a dynamically typed language. We don't really have types here, so what is going on here? It depends. So yeah, this number is taken, it's being turned into parseInt. The problem is not here. It's passed on to this function. Let's just look at this function. Now this function will take that number, and there is a threshold 1000. Okay, there's a surcharge here, and we have this amount value right here that does something interesting with it. It effectively takes that value, now x, and it add that value to a surcharge. But once it do it, it will assign it or cast it to an int32 array. And as you can see, when I hover over it, int32 are these type of arrays are a typed array in a 32, well, it is signed typed array within the JavaScript context. So all the problems that we have effectively in typed languages, when we are using things like that in JavaScript also happen. Why may someone even use things like that? There are a few reasons. Like one of them is performance, that these sort of data types, they perform better than if you just, define something as just as generic as search. By the way, this one is also has a type which JavaScript call it number. So this where apparently things happen, we can see is int32, and then it will goes and compare this value, the result of this arithmetic with threshold, and return true or false. Okay, so that means that from a code review perspective, we just look at these sort of data types, and the other things we're going to look at, and it could not be just in that part of the code that you are looking at, it could be in different components and the files. You want to look for arithmetics, things that done to that value, especially if this value comes from an untrusted source. So in this case is specified by user. So these are the hints when you're doing code review, and and this is like a clear example, very basic example of that. Subtractions, divisions, multiply, anything like that could make this value to go beyond or below the range of that data type. So since the value that we have given is beyond that int32 range, obviously this, as we could expect, this turned into a negative value. And instead of returning true, it returns false. And when it returns false, it says it does not require an approval. So far, so good. I'll just wait a few minutes for anyone trying to catch up to do so. Another thing I just want to add here, just before I forget, is not just arithmetic that result into integer overflow. Casting or typecasting, like when, for example, you assign something from a bigger data type, let's just say long, back to integer, which is smaller than long. That also is a case that integer overflow happen, because if the value is for a long type, which is a lot larger than integer, there is not enough bits to represent it in integer. So what the computer may do may wrap things around. So arithmetic is one thing I will check that, and the other one is casting. Now I know 1 or 2% they also mentioned they know solidity. Now the interesting part is even in the latest version of the solidity, it will take care of arithmetics overflow like that, but when it comes to the casting, it will not, and that is again the job of us to make sure it doesn't happen. Okay, or I'm just looking at the question. Should we try all the languages even if they are? Yeah, sure. I mean, you can pick any of these languages that you have. I picked 3 of them here, like in this game, but you can, this exact issue, I think we have it in Java, C#, Go, Ruby, and yeah, you can try them there too. And in fact, it could be even interesting just to see how in some languages is actually more challenging than the others to address it. I would say in Python, Ruby, and JavaScript is a lot easier to address this. But the approach I'm going to now take is that it's kind of very generic approach that regardless of the language, if you want to address this, probably we want to go that way. Yeah, some may take some shortcuts when it comes to Python, Ruby, and JavaScript to address this. All right, so far so good. Now I think it's a time we move into a little bit of patching and how to remediate it. So what would you suggest as a way for me to go and fix this issue? So as we know, one of the problems, and you can keep your suggestion coming in the chat, it just takes a while for it to show up. As we know, this problem happens when the value, goes beyond that int32 range. So probably one thing I can do is I can check if this value should not go beyond, or I can check if this value went beyond that range, then maybe, I kind of throw an exception or something and say, hey, you can't do that. Parseint. Maybe you try the parseint one, but the problem is actually somewhere else. But let me perhaps talk about one example here. That a way we may go after fixing it. The first pitfall, warning. So I'm going to check if amount 0 is, so which is the result of that arithmetic, not amount 0, because that thing will give me an array, is beyond, well, what was the 32-bit? Because we are dealing with the 32-bit. I don't know the exact number. Let's just do the sum calculation. Just do mass power to 30. So 1 bit is reserved, so 31. So I'm saying if this value went beyond this thing, okay, now give me throw, I don't know, let's just throw a range error. Beyond yeah. So I'm stopping it to go beyond integer. Would that fix the problem? Yes, no. Well, I'm going to the app. The app is running and it's already, my changes has been applied to the app. Let's just go here and hit refresh. It didn't fix the problem. Still, I'm getting, it does not require approval. My expectation is that, well, it should require approval. So, what is going on? Perhaps I didn't thought about, hey, actually, when that arithmetic happens, yes, the result was beyond int32, but now the result is negative. So I'm dealing with a negative number. So the amount 0 is never going to be beyond int32 because that int32 array cannot even represent it. So I cannot even, this sort of check doesn't even make any sense, right? So what if, let's just do something. Let's just put perhaps quite a more restrictive check here. I will just keep that up there. And let's just do another check. We are dealing with a financial value here, like amount. And I want to say, well, for my program, negative amount does not make any sense. So I just want to throw in quite a restrictive check here. I will say, all right, now, if the result of this arithmetic is anything below 0, I'm gonna throw another range. No negative number. I don't like it. And if not, then I will continue with the rest. So, okay. All right, I will come back to that parseint again. You can actually try it yourself to see if that fixed the problem, but let's just continue here. Okay, so, well, let's try. Same value. Hooray. Now I got that exception that I was expecting because, as we talked about, it turned into a negative value. But here is my question. Do you think we have fixed the problem? Definitely we have catered for that case. So if I just, give it a huge number, and let me try with the other numbers just to make sure if the program works as expected. So 10 does not require approval, 1000 requires approval. So yeah, things seems fine, happy days. So have we solved out the problem? Well, unfortunately not. we actually have not addressed the root cause of this issue. And perhaps let's talk about one more exploitation technique here. Well, one more value in your toolbox is that now I'm going to just come up with this number, just not give you that exact number. So we know that the mass power to 31 is this value here. Now, if you just multiply that by 2, you're going to get this value. Now, let's try this value. The app is the same. I just come up with this value. Let me copy. Copy. Wait. Seems like the issue is still there. I have given it definitely a value way beyond 1000, but it is still showing me that it does not require approval. Interesting. It seems like we have a double integer overflow here. I don't know whether that term even exists. But this value that I have given is twice the size of the 2 power 30, but it's 2 power 32, right? So no, the issue is there. So I'm looking for now your suggestions. What do you think, which line I may change to something? Maybe you can tell me a little bit more. Or now one thing I like to avoid here, I don't want to change the data type. So that's for sure. I don't want to change that. I want to keep it as it is. So just say we are locked in to use int32. But I still want to cater for the cases that if this value goes beyond this range, I fix the problem. Any suggestions? You can use the chat to give me some ideas what to do. Or maybe I talk about parseInt one. Well, I don't know which parseInt that was referred to. We have one parseInt here. What parseInt here? Is that the case? Not really, but yeah, it could be impactful. Add a check before returning. Maybe you can point where. Like I'm actually doing a check before returning here. If that's what you mean, or is 2 power 31 minus 1? Well, yeah, but where do I put that check? Make sure the amount is greater than a supplied value. Now, things math, yeah. That is one good way of thinking about. Like you are effectively referring to some properties of, well, when you add two number, so let's just C equals to A plus B. Let's just suppose A and B are both positive values, right? I should always have this condition that C is bigger or equal to A, and C is always bigger to equal than B. That condition, like this is known as like the property of like addition, right? So this should always hold positive or hold valid. Do you think this perhaps can help me to try to address this problem or get rid of int overflow? There was a suggestion that I should check if that amount that is bigger than or equal to the result of that, well, that supplied value which is here, or even the surcharge. So maybe we can try this. So just get rid of this thing here. So one way that we can try to address the root cause here is that by following one of these property of the addition, we can say if, for example, amount 0 is anytime that this value effectively, if it is resulting to become less than, the result of the arithmetic should be always bigger or equal to the value that is used. If it is less than that value, or cases where amount 0 is smaller than surcharge, that should never happen. Well, I should say well, that's definitely a case that an overflow happened or is out of range. Yeah, let's see if that's gonna fix the problem. So if try this value now, it did it. There's perhaps one more thing missing, and that is to deal with the negative numbers, because this assumption is based on that everything is based on positive values. Add it. Maybe now we try this. Would that fix the problem? Try the value. Still does not require approval. So is there anything I'm missing still? Or maybe this approach is not the right one. Question. Maybe I have some syntax error. Could be as simple as that. No, could be. No. Or perhaps leave this as the question, like, so what I'm trying to check here is this result of this value is beyond that given value or not. What is missing perhaps here? Maybe I can print out the amount and see what is inside it, right? So what is going on with that thing? Let's just see. Troubleshoot it a little bit. Fresh, come back to the console log. Gives me 10. So I am sort of dealing with an already overflowed number here. Then the check with the amount. Let's try that. Amount 0 goes negative. Try that. Doesn't seem to be. The value I'm getting is 10. And maybe let's try the other cases. So let me try with the int32 max. Should be -1 perhaps. Try this. So for these cases, yeah, it does print out range error. And if you can see, because this value becomes suddenly negative, and this check will kick in. Of course, is also the other checks I have here. And would that fix the original problem I had? So it was like 9 zeros here or 10 zeros here. Yep. This is perhaps one case I have here, which is with this value. Doesn't work. What I'm missing? Should I perhaps make sure the value is always positive? Would that probably fix the problem? Maybe I try with this value a bit. Perhaps it can gives us some tip. Now, what if I just decrement it by 1? I get a range error. Increment it by 1. I don't get a range error. How about I deduct 10 from it, because that's where the surcharge is added. So is 96. What about 86? I get out of range. And if you look at the result here, console log is a negative value. Oh, sorry, not this one. So because I get 0 in one case, the other case I get 11 because the 10 is added to it. So why these values still just incremented 1 by 1? Perhaps give me some tip. 11, 12. What is the problem still that I haven't catered for? Looking at the chat. Is there anything I'm still missing? Overthinked it? Any tips, suggestions here? Can copy this code. So if you're running this lab, I can copy this here for you. Chat, so you can even try it yourself. Perhaps you can see where the problem could be. I didn't change any parts of this code. The only part is approval function. Value I'm is this one. Often matching doesn't seem to be that straightforward. What do you think the parse int will return? A few times there was a mention of, hey, maybe get rid of that parse int. Let's just try that too. Would that give me a pointer? I'll just do a parse int of the value right here, right at the start, and see what that will out. And the parse int will give me perfectly that value back. It doesn't do much with it. It's because we are dealing with a number type right there, and that is within the range. Do you think I should check? Because by the end of the day, when I'm gonna do this arithmetic here, I'm gonna deal with int32. Do you think I should do some precondition checking? I need to definitely check for the case that, hey, this value, regardless whether it's gonna be beyond or below int32, it should not even be close to int32. Would that help? Some sort of precondition checking? Because definitely that value that I'm passing on is way beyond int32 value range, and maybe I should immediately discard it even. Doesn't make any sense even to do any calculation on it. Would that help? I don't want to kind of solve everything alone, but one technique you can definitely use is precondition checking. So you do reverse of the arithmetic there. So before you adding the number, you will check if the result of this number gonna result into an integer overflow. That's called precondition checking, and that will protect your addition from overflow. Maybe that's one thing you want to check here. The other thing is if those values that are passed on, in this case in this language, we can check if they are beyond the int32 value. So, well, that would be one thing you may want to consider. For example, like if this value here, so parse value, try to, is this bigger than mass dot over 31? So did that work? Well, let's try. Auto French. Now it seems like maybe, but what if I give a negative value of this? Now this is gonna get catered somewhere else. Now this is another number I will leave you with. The negative range of this number. Now what do you think? Do you think are we missing here, or this is work as expected, does not require approval, is even anyways a negative number? What's happening there? All right, so I think we are pretty much toward the end of our workshop today. Now I want to leave you with some interesting things. The issue of the integer overflow, it has created quite a lot of incidents, and one of them, it happened quite a lot in the video games, especially the old school video games. If you just search for, kill screens, there have been games like Pac-Man and a few others that the integer overflow kicks in. And very, very most recently, the game Tetris, people are effectively now playing the levels that those levels are all, was not even in a design of this program. Because of the overflow, now they are playing those, the colors of the page is changing and a lot of other weird things happen. And this is to do with, integer overflow makes that program to behave differently. But interesting enough, that makes the game even more challenging to people to play. One other interesting point is that, which I mentioned this slightly before, not all those microprocessors have this idea of the modulus arithmetic. One of them, graphical processing unit, GPU, effectively it has the majority of them. It implements saturation algorithm, which effectively, if the number gonna go beyond the range, it will clamp down the value. So the number will not go, it kind of stays there. It doesn't wraps around to suddenly become negative. So perhaps an interesting question, why don't we have this in the implementation of our CPU? Anyhow, these challenges will be up there. You may find that the Python version is slightly different from the JavaScript and a Java one. But if you want to really challenge yourself, JavaScript is one of them. Still, there are a few things we need to do there to get rid of the problem. With a specific to the Java, similar story there. I try to use the approach that you can also use it there. The way you want to address it is, of course, by not casting it too long. Now, one thing you should be always doing after you finish doing a lab, and if you're happy with your solution, is to push your lab. And if you have successfully addressed the issue, now in this case of this integer overflow, it does not check for all the cases that I've just tested for. It checks for just in 32 range. It doesn't go beyond it. So as long as those things are addressed within your code, you can test if you have addressed the problems by running make test. So this one is npm test. This will run a number of tests against the code, and if those tests pass, it will result into it means that we have passed the challenge. So let me have a look at this one. I think there is one case I'm missing. Let's just have a look at that. One is this. I think it's the case for arithmetic result and a max value. So the thing I need to do is I need to address this test. Once that is done, like any Git command, you use git add, git commit, fix, and git push. This will push the code to the remote repository, and a number of tests will start against your code. And if we manage to address this issue, we will get the point for this challenge, which I think there are a few points. Still have time to address it. So that was all for today. I guess I hope this was something interesting for you to take away from it. And realizing that some of these security bugs, perhaps the theory sounds simple, but when it comes to the addressing it in a real app, it takes quite a number of other checks to do. And yeah, like always, if you have any questions, please feel free to send to us. And I hope we run some of these AppSec workshops again in near future. Thank you.